We're asked for the length of the diagonal SQ in this setup. So I'm going to just draw that on to begin with. This length here. Now when you're looking at lengths of lines, a good shout is often to use Pythagoras, and that's what we're going to be doing here. We're in fact going to have to extend this and then draw a line going up. This is a parallelogram. So essentially you can imagine cutting a piece off here and moving it there. So what I'm trying to say is this red triangle on the right is half of an equilateral triangle, which means we've got length 1, we've got length 1, and then this will be length a half. So overall, 2.5 or 5/2 for the base. Now this length is also 1 because it's part of the equilateral triangle, and I can now use Pythagoras for the first time to work out the height. 1 squared minus a half squared square rooted becomes 1 minus a quarter, which is 3/4, square rooted, which is √3/2. You can actually also use your exact values of trig if you prefer, because here we've got that sine 60 is going to be this opposite divided by 1, and sine 60 is in fact √3/2. But hey, if you know that, great, but it doesn't take too long to use Pythagoras. So √3/2 for the height, and then finally the diagonal then will be 5/2 squared plus √3/2 squared square rooted equals 25/4 plus, right, square root of 3 squared takes us back to 3, so 3/4. A bit like what we had over here when we square rooted 3/4, we got √3/2, so square it, we get back to 3/4, which is 28/4 square rooted, which is the square root of 7.